In that case, let's move on. To deal with that exact problem, that model, recursive neural networks, depend on a parser, on an external parser, and we don't like that, and you want to work with raw data, you don't want to work with trees, you're going to introduce convolutional neural networks. It's an assignment for you to watch this video. Any questions about CNNs for sentence classification? So while you're thinking of a question to ask, I'm going to give you an overview. A sentence, you can think of it as a sequence of vectors. And we just saw how to do that. Word vector representations is actually turning these integers, 1, 2, 3, those IDs of your words, into actual vectors. Or even if you don't do that, these IDs, you first turn them into one-hot vectors. So whatever that you do, you're going to end up with a sequence of vectors. And a sequence of vectors, you can just put it in a matrix. So each sentence, you can think of it as a matrix. So X is a matrix. And each one of these vectors is k-dimensional. For those of you who know about images, to draw an analogy there, over there, each image was actually a tensor, which is a generalization of matrices. So an image has an X coordinate, it has a Y coordinate, and each pixel is actually a vector, red, green, blue. That's how you think of images. You can think of a sentence as a one-dimensional image. And at each location, you have a vector. If you merge these k values, maybe you end up with a color, and that color is actually your word. But we like to think of them as vectors, and each single vector that you see in this sequence, you can think of it as a pixel. Rather than being three-dimensional, red, green, blue, they have k dimensions. Now that you have a bunch of pixels, you can borrow ideas from images. And convolutional neural networks are originally designed for images. We're going to borrow those ideas and bring them here. And this is exactly what I just mentioned. A sentence, wait for the video and don't rent it, you can think of it as a matrix. Each one of these words is actually a vector. And these are the pixels. For images, you had to take a window of your image and slide it and multiply it by different kernels. Here, your sliding task is actually much simpler. You're sliding in one direction. You don't need to go worry about going right and bottom, right, bottom, or bottom, right. This is a one-dimensional object. What would you do? You pick a filter or a filter size. It's the window of your input sequence that you're going to take a look at. And let's say H is 2. You have W1, W2, and then you're going to slide that over your input sequence. You take X1, multiply it by W1. You take X2, multiply it by W2. These are going to give you two vectors, add them up. And add a bias to it, push it through a nonlinearity, that's going to give you a vector. And then you keep doing that again and again. Then next, once you slide to the right, you're going to take X2 multiplied by W1. You take X3 multiplied by W2, add them up. That's going to give you the next vector. In the end, all you don't need a lot of vectors to work with. You need to turn everything into a single vector. And a good operation for doing it is taking the maximum of all of the vectors that you end up with. That's going to give you a single vector. And this maximum is being done element-wise. Once you end up with a single vector, it's as if you turned your non-tabular sentence into a tabular entry. Now you can actually put it in an Excel spreadsheet. And then the rest of it is just doing regular classification. You have 5 classes in the end. You turn Z to a 5-dimensional vector. You take Y, push it through a softmax. That's going to give you probabilities. Once you have probabilities, you can write down your likelihood and maximize it. There is also a catch about dropouts. And dropout, you can think of it in terms of dropping your neurons. And each neuron, you can think of it as a team member. And the set of neurons is going to give you this vector. And that's going to give you the actual team. You don't want every single team member to be co-adapting to somebody else. You want to introduce some randomness. And that's the role of this R. Sometimes out of that team, you're going to drop somebody and add somebody else. Or you just drop them and a team of 3 members is going to end up having 2 members. And it's exactly like what I do in class. When I create a team, I want to introduce some randomness. Sometimes, some of you, rather than being in a team of 3 students, you're going to end up in a team of 2 students. So one of you dropped out. And then to compensate for that, I said, if I want to be a fair grader, I'm going to give you, if you do 2/3 of the work of a team with 3 members, I'm going to give you the same grade. So your report needs to be 2/3 as good as a report written by a team of 3 members, a full team. It's the same story here. When it comes to prediction, you take your weights and multiply them by the dropout probability. And this you can actually draw the conclusion that this is 2/3 for our example. And the other thing is when you're actually doing the training, there's going to be some randomness going on. When you want to do the testing, you don't want your algorithm to behave randomly when you put it in production. What do I mean? Sometimes you let some emails that are spam end up in the inbox for random reasons. You don't want that to happen. That's why in testing, during testing, everything is going to become deterministic. There is no randomness going on. You're just down weighting your trained weights. And the rest of it is looking at some data. And this is actually what I want you to do. Take it very seriously. Data is a source code for deep learning. Download these data sets and explore them, because these data sets, we are going to keep referring back to them all the time. Any questions about CNNs and sentence classification and dropouts?
Probability that you drop any connection, and then you just multiply all the weights by that probability.
Yes, exactly. So what's going to happen whenever you hear the term dropout, just separate these two in your mind. Training, are you talking about training or are you talking about testing? If you're talking about training, things are going to be random. Each data point that goes in, each sentence that goes in is going to see a random configuration of your neural network. Some of these weights or some of these neurons are just going to drop. You're just going to cancel them out. You're just going to set them to 0. And once you set them to 0, the corresponding weight is not going to get optimized for that particular sentence. So each sentence that goes in, you can think of it as a project. Each project that goes in, a random team is going to work on it. But when it comes to testing, it's a different story. You don't want things to be random anymore. A test sentence is going to go in, and you want to know, is it a spam or not a spam? Is it a positive review? Is it a negative review? You don't want things to be random. When it comes to testing, these weights that you're going to use, you're replacing these W's up there by maybe 2/3 of them, or maybe half of them. You're just going to multiply it by a half. So does that distinction make sense? Did I answer your question?
Yeah. So if you're multiplying by a half, then when you are training, each connection would have like a 50% probability of dropping out.
Exactly.
You want them to be the same?
Yes, exactly.
Thank you.
Sure. Any other questions? And actually, when you're using frameworks like PyTorch or TensorFlow, you're not going to see that distinction, but it's an important distinction to keep in mind. Actually, when you're doing PyTorch, you're going to say model.train, and your model is going to be behaving differently when it comes to training. And then when you're actually doing your testing, you're going to say model.eval. You're evaluating your model. And this is what's going to happen under the hood if you put a dropouts layer in your model. So they already take care of it for you, but behind the scene, this is what is happening.